terjatuh. Good morning, everybody. Let us start today's class. So, in the previous class, we discussed about foundations of AI and applications of AI, and regarding tic-tac-toe game playing. Okay. Coming to the foundations of AI, this particular AI is extensively used in the fields like mathematics, neuroscience, control theory, and linguistics. So, they are the four main fields where AI is used. Okay. Coming to the applications of AI, so it is used in gaming, natural language processing, expert systems, vision systems, speech recognition, handwriting recognition, intelligent robots, etc. So these are some of the applications of AI. Not only these fields, it is also used in various other fields also. Okay? Next, so coming to the next topic, tic-tac-toe game playing. So I discussed about this particular game. So this tic-tac-toe is a two-player game with one player marking O and the other marking as X. Means first player will make his move using circle. And the second player will play the game by marking with X. So if either vertically or horizontally or else in diagonal shape, in whichever means should be in order. Okay, should be in order. Okay. So let me share the screen. So this is a tic-tac-toe complaint. So in Telugu, we can call this particular game as the Dadi game. Dadi. Okay. So okay. So this particular that means actually this particular game will play by two human players. Okay. So here, if you consider this particular game is played by a system or a computer, then one of the player will be a human player, the other player will be a computer program. So here two players will be there. One is a person and the other one is a computer program. These are the two players who play this particular game. Okay. Now the objective to play this game is using computer is to write a program which never loses. Okay, so the objective to play this particular game by using a computer is to write a program which never loses. That means every time the system or the computer should win. That means it should never lose the game. Okay, so that is the objective here. So below are the three approaches to play this game, which increases. Okay. So there are three approaches mainly. So mainly to play this particular game, there are three approaches. Okay. So these three approaches will increase the chances of winning the game. Okay. But there is a slight increase in complexity. That means so complexity gets increased by using the approaches. Okay. So there is an increase in complexity. There is an increase in use of generalization and clarity of their knowledge, next extensibility of their approach. So there are the four. Um, so there are the four things. Okay. One is complexity is increased, generalization use will be increased, knowledge clarity will get increased, and approach and accessibility of the approach will get increased. Okay. Coming to the approaches to play this particular game, first approach is let us represent a 3 into 3 board has 9 elements. That means let us consider a 3 into 3 board. 3 into 3 board means 9 elements will be there. So each element is a vector that contains any of the point. So that particular board, 3 into 3 board, has either 0 or 1 or 2. 0 means blank position. That means a move can be made. And next 1 indicates X player move. And 2 indicates O player move. So here consider two players. One is player O and player X. Okay. So this is the board positions. So first move is initially the board is empty. That's why initially the board is empty. Okay. So see this one. Initially the board is empty. So current board position is all zeros. Total 9 zeros. Okay, next. Now one of the player has made a move. Okay. That is in the position. Okay. We consider that one as now the new board position is position player one indicates X player move. Okay. So first move is made by the X player. Next one. Okay. So this particular board tells us where the particular board is making the move. Okay. So in the next one, in the next position, next player is making. So yeah, both position will be like this. So one will be placed with the starting position. Okay, next one. The player is making a move here. Okay, so it is at eighth position. Okay, and next one. Okay, see every time the player makes a move, uh, it will remove the starting position. Next two will be there. Okay, next one. So like that, every time the move is made, the board position changes. Okay. Now let us see the algorithm. So view the vector of the board as a ternary number. Okay. So get an index by converting this vector to its corresponding decimal number. Okay. So you have to view the vector board as a ternary number. Okay. Next one, get an index by converting this vector to its corresponding decimal number. So that means every time a move is made, it is to be converted to its corresponding decimal number. Okay. Next, so get the vector from the new board position stored at the index. First, this particular board, that means that 3 board has to be viewed as a ternary number. Next, get an index by converting this particular vector to its corresponding decimal number. That means every time a move is made, that particular move is to be converted to its corresponding decimal number. Okay, so initially, it is made, it is made, that is the particular move, whatever move happens there, or uh, whatever move a player makes, that should be converted to its corresponding decimal number every time. Okay. So next, and for the next time, it should get the new board position stored at the index. That means it should take the data from the new board position. Means our new board position has the decimal number promoted vector. So that should be taken from by the current board position, and that should be placed in the current board position. So see here, the same thing done here. Okay, current board position is all zeros. Next, new board position will be like this. That means a move is made by the player. Okay. Next one. After that, this particular board position, it should be converted to the its corresponding decimal number. Right. Okay. So 1. Okay. 1 means so e power 0 equals to 1. So everything power 0 equals to 1. Means the move is made there. Means 1 will be placed over there. So that should be converted to a decimal number. So decimal number means here you'll get the 1 over here. And next one here, new board position now. Board position is all zeros except the first position is 1. Okay, now second move is made. So second move is made. So this should be converted to this particular. Okay, so it should be converted to decimal number. So like that, each and everything will be converted to decimal number whenever a new move is made. Okay. Next, so get the vector from the new board position stored at the index. The vector thus selected represents the way the board will look after the move that should be made. Now, so set the board position equal to that vector. Okay, like that, every time the move is made, that should be converted to decimal number, and that should be stored in the new board position. Next, so advantage of this particular approach is it is very efficient in terms of time. That means it takes less time to make the move. And next disadvantage is it requires a lot of memory space. That means every time the move is made, that should be stored in the database. So it takes more amount of memory. Next, a lot of work is required to specify entries in move table manually. That means manually, every time the entries are made, it should be stored in the table. Okay, so that is the advantage. And next one is this approach cannot be extended to 3D tic-tac-toe as 3 power 27 populations are to be stored. That means only, so here it contains a vector of 3 power 9 elements. 3 power 9 elements. Okay. But according to 3D tic-tac-toe problem, so it should store 3 for 27 both positions. So it is okay. So the current direction is the 3D tic-tac. Okay. Next approach 2 is the board B from 1 to 9 is represented by a 9 element. So here, second approach, the board B that is from 1 to 9 is represented by 9 element vector. So here it is a 9 element vector. Here 2 represents the blank position, 3 represents the first player move, and 5 represents the second player move. Okay. Next. So here we have 3 sub procedures. One is go off and make off to possibility to win of P. Okay. Next in this one, go off and means using the function, using this function, computer can make a move in square error. Go off and means computer will make a move using the function. Okay. Next one. Make of to means the function, this function helps the computer to make valid 2 moves. If it wants to make 2 moves, then make of. Next one. Possibility for P to win. Possibility for P to win. So if player P can win in the next move, then it returns the index from 1 to 9 of the square that constitutes a winning move. Otherwise, it returns 0. That means if the next move is by making a next move, if it wins, then this particular player P returns the index from 1 to 9, or else it returns 0. So this is the second approach. So this particular strategy is applied by human for this game. If the human is winning in the next move, the human plays in the desired square. If human is not winning in the next move, then one checks if the opponent is winning. If so, then log gets square. Otherwise, try making value 2 in any row, column, in any row, column, or diagonal. Plus, the move can be made in a row, or else in a column, or else in diagonal. Okay, so if this particular game is being played by the human wins in the next move, then the human plays in the desired state. Okay. So if by making a next move by the human being, if he wins, then he will play in the desired state. Otherwise, if the human is not winning in the next move, then one checks that the opponent is winning. Okay. So here, if the opponent is winning by making a next move, then it has to block the square and try making value 2 in a row, okay, or a column or gray. Okay. Now let us see the possibility to win. The function possibility to win after checking one at a time for each of rows or columns in diagrams. If possibility possibility will not be equal to 0, then P cannot is made as 0, right? P cannot win. Find whether opponent can win. So then what? This can be as follows. So see this one. 3 into 3 into 3 equals to 18. Let's then explain can win as there is one blank square into row, column or diagonal. Next, if 5 into 5 into 2 equals to 50, then player okay. Because this particular calculation tells us which player can win. If the first one is the case, then X player moves. X player means the first player or the human player. Otherwise, if the second one is the case, then player O can move. And coming to the advantage of this one, it is memory efficient and it is easy to understand. Some of its disadvantages, it is not efficient as first one is expected time. That means this one is a time taking process. And next one, this approach cannot be extended to the detector. So next coming to the third approach. In this approach, we choose a board position to be a magic square of octet. Magic square of octet. Okay. Next, blocks numbered by magic number. The magic square of order n contains n square distinct numbers from 1 to n square. Such that the numbers in our rows or columns input diagonal sum to 15. This is the magic square. Okay. That means every number should be there and number should be repeated only one at a time. And by vertically or horizontally, we count the sum, then it should be equal to 15. That's the magic square. So see this one, 8 plus 1 plus 6, 15. And next 8 plus 3 plus 4, 15. And next 1 plus 5 plus 9, 15. 6 plus 7 plus 2, 15. And next 3 plus 5 plus 7, 15. Next 4 plus 9 plus 2, 15. And then either the horizontally or vertically, if you count the sum, that should be equal to 15. In this approach, we will list of blocks played by each player. And for convenience, each block is identified by its number. So this particular strategy for possible win for the player. So let's see the approach. Each pair of blocks, a player owns is considered. Yes. So that should be number. So the move should be number. Next one, difference d between 15 and the sum of the two blocks is completed. So difference d between 15 and the sum of the two blocks is completed. Sum of the two blocks should be completed, and it should be compared with the and should be different, and it should be made as difference from 19 from 15. That means, for example, in order to get the next move, so the first two blocks are to be added, and that should be made as different. And that should be difference from the 15. Then you will get the one value. That value should be fill in the block. Okay. Okay. Mm. Okay. So, let's see this one. Each pair of blocks a player owns considered. Difference d between 15 and the sum of two blocks is 20. So now we consider. So there, if t is less than 0 or t greater than 1, then these two blocks are not collinear. and so can be ignored. Okay, so you have to check the condition there. If the condition is satisfied, then the two blocks are not collinear and they can be ignored. If the condition is not satisfied, then if the block representing reference is blank or not in either list, then player can move in the block. That means whether a move can be made in the next block or not, that should be considered. Okay. Next. So this strategy will produce a possible win for a team. No, wait. Now let's see how to execute the here human uses mind and machine uses character. Assume that machine is the first player. So consider machine as the first player here. So move one machine will take the element. So suppose machine takes the element 5. Now move to element by the human. It takes the element 8 for example. Okay. Now machine 3. Next one. Machine move 3. Machine takes the element 4 for example. Okay. So the machine elements contains 5 and 4. Okay. Next one, human takes the element 6 here. Okay. So the human elements contain 8 and 6. Now machine is to make a move. From the above moves, machine has the elements 5 and 4. Now first machine checks whether it can win. Okay. 5 plus 4 equals to 9. 15 minus 9 equals to 6. Since the element 6 is already taken by the human, there is no possibility of machine elements. Okay. Now machine checks whether human can win or not. So the elements taken by human are 8 and 6. So 8 plus 6 equals to 14. 15 minus 14 equals to 1. So the element 1 is out from the machine. It takes the element 1. Finally, the elements taken by the machine are 5, 4, 1. Okay. Now, okay. So whatever move, either a machine or a human being, so it should make the move so that the opponent should not hit. So the move should be made by that particular the move should be made in that particular block so that the opponent could not hit. The move should be made like that. So if that particular block is filled by the suppose I want to win. So I need to think in the opponent's using the opponent's mindset. That means whatever move I make, that that move should be made by me so that the opponent could not. So in that way, I need to make a move. Next. So now the machine has taken 5, 4, 1. Okay. Uh, so this, those particular numbers are nothing but whether the particular field should be filled or not with some number. If that particular number is placed in the particular block, then the opponent will win. Okay. So I need to make a move so that the opponent could not win. In that way, I need to think and I need to make a move. Okay. Next one. So the human takes the element 3 here. 3 here. Okay. Next, so the human element contains 8, 6, and 8, 6, and 3. Okay, now move 7. It considers all the elements taking the 5, 4, 1. So 5, 4, 1 are the machine's elements. Now 5 plus 1 equals to 6. 5 plus 1 equals to 6. And 50 minus 6 equals to 9. So since the element 9 is available, machine takes the element 9. Okay. Next, therefore 1 plus 5 plus 5 plus 1 plus 9 equals to 15, which leads to machine invested. Okay. So like that, I need to make a move so that the opponent should not win. Okay. That way, I need to make a move. Yeah, advantage of this particular approaches, it could be extended to three-dimensional tic-tac. And the disadvantage is it requires more time than other two approaches, as it must search a tree representing all possible moves sequences before making each one. Okay. Next one. Coming to the next one. So this and disadvantage is it requires more time than other two approaches. So more time will be taken by this particular approach because it should search the tree representing all possible move sequences before making each move. It means it should be, that means the searching process only takes more. So it should need to search whether that particular element is available or not, and that position is available or not, like that. Okay. So that is the result. Coming to the development of AI languages. Okay. It is based on AI languages uh, have been derived or these are represented, or the AI languages are represented in the following languages like Lisp, Lisp processing, Prolog, so logical processing, next one POP2, next one machine learning. So these are the various languages with which the AI has been Lisp, Prolog, POP2, and machine learning. So this particular Lisp is a functional language based on lambda calculus. And next one Prolog. So this is a first order predicate logic. First order predicate logic. And the above Lisp and Prolog are these two are declarative language. Where one of the languages tells one of the language tells us what to compute and not how to compute. Because it doesn't tell how to compute. It just tells what to compute. That is what should be computed. What should be computed. Okay. Next one, POP. So it is based on stack-based language that provides greater flexibility, and it is similar to this programming language. Next one, machine learning. It's an application of AI that provides systems the ability to automatically learn and improve on experience without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it to learn from themselves. The primary aim of this particular language is to allow the computers to learn automatically without human intervention. Means without human intervention, this particular programming language learns on its own. Okay. And coming to the current trends in AI, so it is a hard computing language, hard computing techniques. So the contents in AI are hard computing techniques, soft computing techniques. So there are two types of things. One is hard computing and soft computing. With hard computing or conventional computing, so it is based on the concept of precise model and analyzing to yield accurate results. So this particular technique works well for simple problems, but is bound by anti-complete set. It includes the problems that often occur in biology, medicine, humanities, mathematics, science. And coming to the second one, soft computing. Soft computing is a formal computer science area which refers to a collection of computational techniques in computer science, machine learning, and some of the engineering disciplines, studying, modeling, analyzing, all this. Coming to the components of soft computing includes neural networks, fuzzy systems, evolutionary algorithms, swarm intelligence, etc. And coming to the fields where this particular AI is used are neural networks, fuzzy logic, evolutionary techniques, genetic algorithms, and poly algorithms, swarm intelligence, expert systems, agent technology, all this. Coming to neural networks have been developed based on functioning of human brains. Because this particular neural networks tells us how the communication is being done between the brain and the nerves. Brain and the nerves. Okay. And next, so attempts to model the biological neuron have led to the development of this particular field, which is known as artificial neural network. So this particular thing is based on. So this particular field is based on neurons. That means in a human body, how the communication takes place between the brain and the nerves have been virtualized, and in that particular way only, this particular that means the research is being done on how communication is being done between the nerves and the brain. So based on the research done over there, so this particular artificial neural networks were introduced. Okay. Artificial, that means neural networks is based on research in research on neurons, and neural networks have been developed. And the name for this particular neurons is artificial neural network. And coming to the next one, fuzzy logic. So this particular fuzzy logic is a method of reasoning. Is a method of reasoning that resembles human reasoning. That means for each and everything, some reason should be there. That means how that is done and why it is done like that. That means the reason for each and everything, a reason should be there. Okay. So fuzzy logic is a method that resembles the human reason. The approach of fuzzy logic imitates the way of decision making in human that involves all intermediate possibilities between digital values yes and no. That means if that is possible, then yes. If that is not possible, no. Okay. And in computers, we can use the input. We can use the we can give the input to the computer, and the computer produces the output as true or false. So means uh, in our view, yes means in computer's view true, and in our view, if it is no, then in computer's view point of view, it is false. It means true equal to yes, false equal to no. Like okay. So this is based on so this particular fuzzy logic is based on human reasoning. And next coming to the next one, evolutionary techniques. It involves meta-heuristic optimization algorithms like swarm intelligence and evolutionary algorithms. Okay, and in the next topics, we're going to discuss all those. Next, genetic algorithms. So these were developed mainly by emulating nature and behavior of biological chromosome. That means based on the chromosomes the human beings have, it resembles this thing, genetic algorithms. That means based on genes. Based on the genes in human body, these particular genetic algorithms were developed. Okay, and next one, ant colony algorithms. So these particular ant colony algorithms were developed to emulate the behavior of real ants. Okay, so this algorithm is the one in which a set of artificial ants or agents cooperate to find a solution of a problem by exchanging information on graph edges. So you already know about the graphs and edges, graph edges or graph. So in this particular graph, some edges will be there. So that means from one edge to another edge, there will be a way. If there is a way, then the communication will be done on that particular way, by carrying the information. Okay, that's nothing but ant colony algorithms. So in this, the artificial ants or the agents will cooperate with one another like ants, and they will find the solution to the problem. So how this particular problem will be solved is by exchanging information on graph edges. Next one, swarm intelligence. So it is a type of artificial intelligence based on the collective behavior of decentralized, self-organized systems. So just like ants, bees, wasps, and termites perform their tasks, so the tasks are independent of other members of the colony. However, they are able to solve the complex problems emerging in their daily lives by by cooperating with one another. They're going to solve the problems. So this particular self-organization by a group of social insects like ants, bees, wasps, and termites. This particular intelligence is known as swarm intelligence. Swarm, SWR. Next, expert systems. So it is an attractive field that is practically used in our real life. That resembles the real life. Okay. Next, emergence of agent technology as a subfield of AI is a significant paradigm shift for software development and breakthrough as a new revolution. Agent technology. Okay. Uh, okay. Next one. Agents are generally suited as someone and are capable of taking autonomous decisions by solving the problem. That means these particular agents will take the decisions on their own. That is individually while solving the problem. So coming to multi-agent systems, on one number of agents will be there. In multi-agent systems, these are designed using certain independent and interacting agents to solve the problems of distributed nature. That means each and everything will be distributed with one another between the agents. Okay. So this is regarding today's class. I already told you that I should be here by 9. My class starts at 9 o'clock. It should be by 9:05 or 9:10. But many are coming after 9:10 also. Here today only 59 or 60 members are present at 9:10. That is in between 9 to 9:10. Only 59 or 60 members were there. The remaining all came after 9:10 only. So I already told many times, please be attentive and please be on time. But you are not maintaining the time, right? So that particular thing will make you to lose attendance. Really many times, please be on time, right? Please try to be on time for the next for my next class. And right, okay, please be on time, don't be late, right? You should be, if the class starts at a particular time, you should be by just 5 or 10 minutes late. Please don't be late more than 5 or 10 minutes. Okay. Thank you.